All right, we're going to take a look at some questions like those on your project. Again, these are not the exact same numbers, but they are similar problems. One problem we'll have with this one, the biggest issue is the fact that we're using fractions, and a lot of people don't enjoy those. But let's go through this and talk about how we would go about it. It said a billiard triangle is equilateral. What does equilateral mean? It means all the sides are exactly the same length. What is its perimeter? So we could easily find the perimeter as long as we know the length of a side. Problem is we don't know the length of any of the sides, and that's what we're going to have to deal with here. We know that this one is 2x plus 4 and this one is 4x minus 6 1/4. Problem is that doesn't help us. We need it without x's in it. So we start by setting up an equation that would allow us to solve for x. Again, what we know, since this is equilateral, is that 2x plus 4 should equal 4x minus 6 1/4. So that's what we're going to start from. 2x plus 4 is equal to 4x minus 6 1/4. We want to solve for x. So we want to move the x's to the same side. So I have a positive 2x here. I'm going to subtract it. Whatever I do on one side, I have to do the other, so I subtract 2x here. So now I have just a 4 left on the left-hand side. Over here, 4 minus 2 gives me 2x. And again, minus 6 1/4. I want to get the x's all alone now, so I need to remove that 6 1/4. To do that, I'm going to add 6 1/4, do the opposite of what was there. Add 6 1/4 to this side. Now I know we're afraid of fractions. That this first fraction step is not too bad. You just add the whole numbers. 4 plus 6 is 10. Add the fractions. No fraction plus a fourth is just a fourth. So I get 2x equals 1/4. Next, we need to divide both sides by 2. Okay, divide by 2, divide by 2. So our answer is going to be whatever 10 1/4 divided by 2 is equal to. Now, this is going to bring us into how do we divide with fractions. Well, first things first, this number 10 1/4 needs to be written as an improper fraction. So we convert it back. We take our whole number 10 in front times the denominator of 4. 10 times 4 is 40. And then you add the number that was on the top. If you think about it, you're adding up how many pieces you have. So if you have 10 whole pies, but they're cut into pieces of 4, that's 40 pieces. Plus you had 1/4 of a pie, so that was one more piece. 41/4. We're dividing that by 2. Now, how do you divide fractions? Well, first we would need to put the 2 over 1 so that it's written out in fraction form. And then the rule is that you flip your fraction and change this to multiplication. So that gives us 41/4 times 1/2. Multiply top times top, 41, and bottom times bottom, 4 times 2 is 8. So we get that x is 41/8. We're not done, however, because our job was to find the perimeter. We needed to find x so that we could substitute it back into either of these to find the length of one side. Once we have the length of a side, we'll have it really easy. We'll just have to add the sides together to get the perimeter. So step 1 is done. We know that the measure of x is 41/8. So next job is to replace that x in our measure with 41/8. What does that give me? Well, first I have to do 4 times 41/8. So again, you do the top times the top. 4 times 41 is 164/8, because that would have been 1 times 1 on the bottom, or excuse me, 1 times 8, minus 6 1/4. Well, let's change our fraction here back into simpler form, since we have fraction here that's in simplest form. So to do that, you take 8 and divide it into 64. 164. 8 goes into 164 20 times, with a remainder of 4. So I have 20 and 4/8 minus 6 and a fourth. Now we have a new problem. We don't have a common denominator, but luckily notice this one will reduce so that we have fourths and fourths. We can reduce this. 8 divided by 2. How many fourths is 4/8? 8 divided by 2 gives me 4, and 4 divided by 2 gives me 2. Now I can subtract because I have a common denominator. 20 minus 6 is 14, and 2 minus 1 is a fourth. Now I know, if you have a calculator fraction button, none of this would have been a problem. But if you didn't, those are the steps. So you do have to deal with addition here, division of fractions here, little multiplication, and then simplifying here. But what do we get? That the length of one side is 14 and a fourth. That means, since this is equilateral, that all four sides, all 3 sides here are 14 and a fourth. So the perimeter of something is to add all of the sides together. So we have 14 and a fourth plus 14 and a fourth, or you could just actually multiply by 3. But if you don't like multiplying, you can add them together. So I have 14 plus 14 plus 14 gives me 42. And a fourth plus a fourth plus a fourth is 3/4. So the answer, the perimeter of this equilateral triangle, is 42 and 3/4. So again, a pretty simple problem that was made more complicated by the fact that they gave us fractions to work with. Here we have a triangular trellis, RST, that measures 84, 84, and 34 degrees respectively. Okay, so we have a triangular trellis. Notice 2 of the angles are the same. So I'm going to try and draw the triangle. What kind of triangle has 2 angles the same? Remember we talked about isosceles triangles. If you have 2 sides the same, you also have 2 angles the same. So 84, 84, and 34. It said respectively, which meant the first number was R, the second number was S, and the last number was T. So R, S, and T. If the length of ST is 2y plus 8, I'm going to label that. So the line going from S to T has a length of 2y plus 8. TR has a length of 8y minus 28. So the line going from T to R is 8y minus 28. What is the value of y? Well, we're using the converse of the isosceles triangle theorem here. We know we have 2 congruent angles, so that tells us that we also have the angles across, or excuse me, the sides across from those angles are congruent. So what does that tell us? It tells us the 2 sides they gave us, ST and TR, are equal in measure. We fill in what they're equal to. So that gives us that 2y plus 8 would have to equal 8y minus 28. And then we have this equation that we need to solve. Get the y's on the same side by subtracting 2y from both sides. That gives me just an 8 on the left side equals 8 minus 2 is 6y minus 28 on the right hand side. I'm going to now add 28 to both sides so that we can get the the y all by itself. I add 28 here, which means I have to also add 28 on the other side, and I'm left with 36 is equal to 6y. Last step, we have 6 times y, so we do the opposite and divide both sides by 6. 36 divided by 6 is 6. So what is the value of y? Y is 6. What is the value of x in the figure below? Okay, so let's take a look at what we have. Based on the lesson we're in right now, remember that 2 sides the same length in a triangle means it's isosceles. The isosceles triangle theorem, which we studied in this lesson, said that when you have two congruent sides, the angles opposite those sides, so this angle here and this 34-degree angle here, are congruent. That is what the isosceles triangle theorem tells us. So if this angle is 34 degrees, that means that this one here would also have to be 34 degrees. I'm trying to find x. What good does that do me? Well, if we think a little forward, remember that one property we studied in our geometry class is that when you have two lines intersecting and the angles across that intersection of one another, they were called vertical angles. And vertical angles are congruent. So if this angle is measure x, the vertical angle paired that goes with it would also be x degrees. Now we are just dealing with a single triangle, which makes our life a whole lot easier. Okay, we can just deal with this triangle here. In that triangle, we know all three angles, and we also know the property that in a triangle, the angles should add to be 180. So we have a 34-degree angle here, plus our second 34-degree angle, plus whatever our x is. Together, those things need to be 180 degrees, and we just use that to solve for x. So I combined 34 plus 34 is 68. And now subtract 68 from both sides, and we will find the measure of our missing angle. When I do that, I get 112 degrees.